Hi guys, so I'm talking about complementary cofunctions. So for sine, the complementary cofunction of sine is cosine. And for tangent, the complementary cofunction of tangent is cotangent. And for secant, which is a reverse trig form for cosine. Oops, so you don't spell like that. Secant, it'll be cosecant. So notice how there's co before every word. So like for example here, cosecant, cotangent, and cosine. So that's one way of remembering of them being the complementary cofunctions for the previous trig functions. So if you notice towards the right, there are formulas. So sine theta equals cosine 90 minus theta. Secant theta equals cosecant 90 minus theta. And tangent theta equals cotangent 90 minus theta. So these are the complementary cofunctions formulas. So towards the right of the formulas, there's an example. So sine 32, and 32 is theta, equals cosine 90 minus 32. So cosine 90 minus theta. And 58 is the answer for 90 minus 32. So sine 32 equals cosine of 58. And remember, this is only for complementary cofunctions. So for 90-degree angle functions. So let me draw a triangle for a better visual. And you're only supposed to use these formulas when you're trying to solve for complementary cofunctions. And if it's in a test or in a worksheet, then it's better if you make a triangle and remember these formulas. I recommend you writing these formulas on a flashcard and remembering them, and yeah. So over here, this angle is 32 degrees. And obviously, this is a 90-degree angle. And over here, this is 58 degrees. So after you do 90 minus 32, I got 58 over here. So sine 32 equals opposite over hypotenuse. So remember, sine is opposite. So the yellow represents opposite over hypotenuse. So the pink represents hypotenuse. So let's say, do a different color. So let's say this represents y, and the hypotenuse represents z. So sine of 32 will equal y over z, opposite over hypotenuse. Now for cosine of 58, it's adjacent over hypotenuse. So the y, which is the side next to 58 with the angle, it'll be y over z. And now for this other triangle over here towards the left, this side equals, let me do a different, same color. This side equals 17. And I did that on my calculator, which is from doing Pythagorean theorem, which is a squared plus b squared equals c squared. And then you squared c, which equals 17. So sine of theta equals 8 over 17, which is opposite over hypotenuse. Cosine of theta equals 15 over 17, adjacent over hypotenuse. And tangent of theta equals 8 over 15. Now let's find the reverse. So cosecant of theta, so you just run a reciprocal of sine, which will be 17 over 8. For secant of theta, which is reverse of cosine, not reverse, sorry, reciprocal, it is 17 over 15. And cotangent of theta, just the reciprocal of tangent, equal 15 over 8. So now, I'll teach you the other tree trig ratio forms for co-complementary functions. So to find cosine of theta, you do sine 90 minus theta. Which equals 15 over 17. Because cosine of theta equals 15 over 17. Equals. Now to find tangent of theta, you do cotangent 90 minus theta. Which equals 8 over 15. Because tangent of theta is same as cotangent 90 minus theta, and tangent of theta equals 8 over 15. And to find sine, to find sine of theta, as it said before in the early formulas, to find sine of theta equals, do cosine 90 minus theta, which equals 8 over 17. And now, so you already know this formula over here. Well, the other formula that's new, which is secant 90 minus theta, it equals 17 over 8. Because secant of 90 minus theta equals cosecant of theta. So both of these are the same. Cosecant of theta equals 17 over 8. So this is what I have for now. So remember these three trig co-complementary functions. So sine equals cosine, tangent not equals, sorry. The co-complementary function of sine is cosine. And the same thing is for tangent and secant. And then remember the formulas that are towards the right, which are on the top. So write them on flashcards or paper or however you like to study. And yeah. And also, when a problem asks you to do these functions, the formulas will come in handy a lot. So the formulas are a big part of this lesson. So in my next video, I'm going to review back to the 6 trig functions I did before in my 2 videos, and I'll give examples for those.